So you should have your note packet out to 11.1a on simplifying rational expressions. So Miss Shiro will wait till every single person has their note packet out, and then we'll get the notes taken care of. Our objective in this section is to be able to simplify, which means get it as far down as possible, rational expressions. And you've actually done that before on a very simple scale, like in elementary school when you first started working with fractions. You knew you couldn't leave 2/4 when you got an answer. You had to simplify that. And you would say, well, I've got to divide out a 2 and divide out a 2, and this is considered simplified. Well, when we bump that up a little bit into the algebra realm, we don't really call that a fraction. We're now going to call it a rational expression. And when it says here, what does rational mean? It means a fraction, but even more than that, it means you're going to have a polynomial, some expression with x's in it over another polynomial. So your fraction consists of a polynomial over a polynomial. And our objective is going to be to simplify that polynomial over a polynomial as much as possible. All right, so our goal is going to be to simplify it. Well, in order to talk about the steps for when it's an algebraic one, what again I'm going to do is let's go back and review way back to something you already know how to do. You already know how to do it when there aren't polynomials. For example, when it's technically 15 is a polynomial, it's a constant, but you never called the number 15 a polynomial in your elementary school days, but you were taught how to simplify it. And the way they taught you is they would say, well, you know what, these have a 5 in common, so you're going to divide out a 5, and you're going to simplify it to 3/7, and that should obviously look really familiar to you. However, what I'd like you to think about it more as here, and what would be more helpful, is almost instead of thinking of it as dividing out a 5, think of it as recognizing that they both have a 5 in them. So notice what I'm doing. I'm kind of thinking it as rewriting 15 as 3 times 5 and rewriting 35 as 7 times 5. And I can notice I have a common factor which actually cancels to equal 1. That's actually the thought process I'd like you to use for the polynomial ones. So yes, you're dividing out a 5, but when we get to the polynomials later on, I really want you to think of almost more like breaking it apart or factoring and canceling. So when it says, what did you do? Really what you ultimately did is you canceled or divided out a 5. And so our goal is canceling. What's hiding in there that we can cancel out? Now if I just add a couple variables on the top and on the bottom, again, you can approach it with kind of more of an elementary school approach, which is fine. I mean, since it's just a single fraction and it's easy to see. Again, all I've done with my 15/17 here is tack some x's on, which means 15 over 35, those numbers out front there, will still cancel to equal 3/7. You're still going to kind of think of, okay, I'm going to cancel out a 5, or divide out a 5, cancel out a 5. That's 3/7. But I also have x's that cancel. I have 3 of them on the top and 2 of them on the bottom. So 2 of these on the bottom will cancel out 2 of them on the top. So basically I'm dividing or canceling or factoring out 2 of them, and it leaves 1 on the top. And I'm okay with you doing that kind like that. However, the deeper thought process behind it is going to have to get applied to some of the harder ones. So I'd also like you furthermore to kind of consider it like this. Again, I won't make you write them out along this red path. You can go ahead and simplify this right down directly using methods from 5th and 6th and 7th grade. But really what you're doing is this. You're saying the top has a 5 in it and the bottom has a 5 in it. So I'm going to break it apart or factor it. The top has 3 x's, whereas the bottom has 2 x's. And really what we're doing is canceling anything that's common to the top and to the bottom. And what's left gives me my answer. And notice I have 3x over 7. So for one like this, again, I don't really care which way you think about it for the easier ones, but when I move along, that whole concept of factoring is really important. So This is what's not okay, and it's what a lot of kids like to do. They like to say, oh, she said that what I can take out of the top, I can take out of the bottom. As long as it's a product or multiplication, that's legal. This is not okay, though. You can't say, oh, I'm going to take a 5 out of here and a 5 out of here. You can't do that with addition. Let me show you why with a more easy to understand problem. Suppose you were to say, what is 8 plus 2 divided by 2? You know that's 10 over 2. You know the answer is 5. But now it's tempting with all this canceling to say, hey, the answer is 8 because the 2's cancel. But that's not the case. 2 is not considered a factor. It's part of a sum. And so basically what we like to say, what makes it easy to remember, is if something's living next to a plus or a minus, it's not a factor and it cannot be canceled. So let's go take a look at number 3 and talk about how maybe you're going to be tempted just to cancel off these x's. Don't do that, all right? You can't cancel them because they're not part of a product. This is x minus 3, not x times 3, which means x is not really a factor there. So when it says why can't I, it's because they're not factors. And again, don't cancel it if it's living next to an addition or part of an addition or a subtraction problem, because that's not a legal thing to do, and I just showed you why. 8 plus 2 over 2 is not 8, all right? It's 5, and so we can only factor if it's part of multiplication. And so let's go take a look. Cancel if it's part of multiplication. So what I want to do here is go take a look at the top. Our number one thing is going to be to factor everything so we can see if there's canceling. And on the top there, you should notice that they are both even, which means a 2 can be factored out of the top. And again, if I multiply that 2 back in, I'd have 2x minus 6. So I'm breaking the top apart into its factors. Kind of like up here, I broke the 15 apart into its factors. I want to see what's going to cancel because when it's a polynomial, it's not so easy. We could easily see that a 5 cancels out of this. But here, trying to locate that common factor requires actually breaking it apart. So on the bottom, I have an x minus 3. Now notice, this is 2 times x minus 3. It's not plus or minus. This is a factor, and it's got the same factor on the bottom. Had x maybe been an 8, just pretend. So my answer is 2. Had x been an 8, okay, the top would have been a 5, and the bottom would have been a 5. And it would have been 2 times 5 over 5, and I could have canceled them. So notice I get to cancel common factors top to bottom. All right, so let's go look at the next one. Again, it's going to be really tempting for you to start slashing things right away. But number one thing you have to remember, go ahead and write it on the side over here, is that you need to factor first before you do any canceling. You can't just start canceling the x squareds out. They live next to a plus or a minus. You need to go to the top and factor it. And how do we factor our trinomials? Well, this is why I had to do the factor review. We unfoil them. We lead in x's, and what multiplies to equal 18? 3 and 6, yes, but they don't give me the 11. 9 and 2, yes. And we want you to be really quick with that factoring. So there's my top, broken into x minus 9 times x minus 2. On the bottom, how can I get the 8? Well, 8 and 1, but there's no way to get a 2 out of those, or 4 and 2. Could I get a 2 out of those? Certainly, as long as the 2 is negative. And then look, I multiply to equal negative 8, so my last will be locked in, and I add up to positive 2. So my outside and inside, when I FOIL, will be locked in. So I end up with an x plus 4 times an x minus 2. What that means is I have a common factor. Again, this means multiply and multiply in between there. So I get to cancel common factors. And it's done. My answer would be x minus 9 over x plus 4. All right, and that would be my final answer for that one. Let's go look at number 5. Again, I don't start canceling. I don't say, oh, there's a 5 and 15 and a 5 and 10. Let's go cancel them. Because this is subtraction. It can only be multiplication. Again, if any part of it is living next to a plus or minus, you do not cancel. And I know I've said that a lot, but it's so common. I even see it in calculus a lot. they do trig, and they'll have something called sine of an angle over cosine of an angle, and they love just to cancel those off, but I can't, because it's living next to a plus or a minus. So it applies even to the higher levels of mathematics also. It's a very common math mistake. So what I need to do is on the bottom, I have to, again, factor this. Well, they have a 10 in common. I'll factor the 10 out of both of these terms. Now, because I'm dealing with a product or multiplication, now I can look for common factors. It's the lunch hour while I'm recording this. So I've got a 5 living on the top. So I'm going to divide out a 5. You might want to consider that 5 times 3 on the top, 5 times 2 on the bottom. But I'm going to divide out a 5 and divide out a 5. And my answer would be 3 over 2 times x minus 1. All right, so let's move on to the next page here. And it says summary. It looks like there's really just two main things we do when we're simplifying the polynomials. The first thing we do before we do anything is we look for any kind of factoring that we can do. We did a whole factor worksheet yesterday, so you should be spotting that factoring pretty quickly. By the way, if you're not factoring first, you're almost always going to get it wrong. Then once we factor, we cancel common factors. If I had to sum up today's lesson in one sentence, there it is. Factor, cancel. Say it 20 times together. Ready? Go. Factor, cancel, factor, cancel, factor, cancel, factor, factor. Anyway, forget it. That wasn't as fun as I thought it was going to be. All right, let's go to the top. What do I do first? Factor. What do I do? Factor. What do I do first, Luke? Factor. Can I cancel? No, factor. How about if I cancel the 3? Factor. Can I cancel ours? No. Factor. What do I do? Factor. Factor. Everybody's favorite F word. Factor, 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 factor. And factor at the top. All right. Miss Sheila, what do they do? Factor. Excellent. All right, so on the top, what can I pull out of the top to start with? And you should look at that and pull out a 3. I'm going to divide factor out of 3, factor out of 3, and factor out a 3. What am I going to do on the bottom? Factor. All right? It has nothing I can pull out of it. However, it's that trinomial, and I'm going to look and see if I can unfoil it. 10 and 7 pop into my head. As long as the 10 is negative, I can factor that into r minus 10 times r plus 7. We should be really good at our factoring now. We've been doing it for a long time. The only one who shouldn't maybe be that fast at it is Miss Shiro herself, because she just started it a couple days ago. All right, so let's go take a look at the top. This factors farther. Okay, I can see that 30 is 10 times 3, and I can get that minus 13 in there as long as they're both negative. By the way, when your goal is to cancel, odds are you're going to get a common factor on the top and the bottom. So once I had that r minus 10 on the bottom, I kind of knew I was probably going to get one on the top. It's a little trick of the trade there. So this is what cancels. Notice nothing cancels at the beginning because I factor first. And I swear to the good Lord above, when I get about 5 of you taking your pencil or your marker or your pen and just start canceling right away, I'm going to probably get sent right back to the hospital because you have to factor first, and I will have a case of extreme rage, math rage, and I will want to explode. So, let's repeat. What do? Factor first, then cancel. And if it lives next to a plus or minus, don't touch it until after you factor. So your assignment, you're going to be given a packet. It's got the next 5 days of homework in it. It's got 11.1a, b, 11.2a, b, and then there's circled ones that we're going to skip and come back to review. So you do all your work on a separate sheet of paper. There are answers provided, so you'll know if you're doing it right because the answer's there. If all you do is turn in the answers, I will give you a 0. So I want to see the work to get the answer that's in the packet on a separate sheet of paper. So today's assignment is 11.1a, all of the non-circle problems on a separate sheet of paper. Due tomorrow. You guys have a spectacular rest of your day.